Okay, so like I said, we're going to talk about classes today. So yeah. Okay, so what's a class? So a class is, it's just like, yeah, I guess like it says here, a blueprint or template for an object. So when you create an object, it follows some sort of structure. It has some attributes, some methods. And yeah, and from each class, you can have like multiple objects from it. So I can have like, if I made a class for like, I don't know, a sports team or something, I can have like multiple sports teams, right? With different names and players and whatever. Yeah, so like these are methods, these are attributes. Attributes are just things that it has, and we'll get into that in a second. Okay, so what is an object? So objects are like, yeah, entities that derive from classes. So, well, and specifically like every object derives from the object class, but that's not really important. But okay, yeah, like objects in general are, yeah, like entities. So kind of like I said with teams, sports teams or whatever, but we can also like person. So like person, a new person is a new person. So we kind of model after real things. So a person, for example, in real life might have a name and might have an age, the city they live in, where they're from or whatever, and like the gender. And so those things, right, are part of what makes a person a person. So we kind of define objects as they have things that kind of define them, right? So in this example, we just say, okay, a person, these are like the only 4 things a person has, but every person has them, right? And they have a name, an age, a city, a gender. Like that's what defines a person, is those things together. Now, obviously in real life, it might be different, but that's kind of how we can think of objects, right? Like inanimate objects, we do think of that way, right? They just have like things that kind of make them up, right? And that's how we write objects in code. Yeah. And just like here, notice how like Bill and Margaret are different people. They have different attributes. And yeah, they're different right here. Like they have different attributes and they're different people. But they both come from the same class, person. So like I'm a person and like you guys are all people, I think. And yet we might have different attributes, right? Okay. So classes and objects, yeah. So every time you make an object, it does the constructor, right? It executes the constructor of that class that makes the object. So, right, if I have a person, like person A, like person A equals new person, it's gonna go ahead and do like go straight to the constructor. Now, the constructor, if you don't write one, the one will be provided for you. It's just going to provide a no argument constructor, which means the constructor won't have anything that it takes in. But it's provided for you unless you write your own constructor, in which case you have to write the no argument one as well. So right, the constructor will look a lot like the class name. So like it's class person, and then the constructor has the same exact name, but it doesn't have a return type. So no void, string, yeah, no int, right? And you can overload a constructor. We'll get into overloading, I think, next week. I'm not sure that's so important this week. But yeah, that will be important in the future, but don't worry about what it means yet. Yeah, and all classes have to have a constructor, like I said, because when you create an object, if you want to create that object, you have to have a constructor for it. Like even if you don't write it yourself, one will be written like automatically. Okay. So let's talk a little bit, like let's look at this example, right? We had like person, Bill, and like person, Margaret, right? Now, both of them like derive from the same class. Like both of them are just person, right? But they're like both of them are people, right? They both come from person, and yet they're different. So that's because we can like have multiple instances of the same class. So, like just how before, let's think like you can make multiple scanners or like even multiple strings, right? You could do like string A equals, I don't know, hello, and string B equals goodbye, right? My handwriting is horrible. But yeah, even though you can have those and like they have different names, like variable names, like, and they both are strings, they might be different, right? And that's what objects are, right? They come from the same class, they're both person, but they're different. And okay, and what happens in this code? So in this code in particular, right, we have a name, an age, a city, and a gender. So these get passed right into this constructor, because when we use the new keyword, that's when we call the constructor. We invoke the constructor of the object because it's creating an object. So that's when the constructor is called, when we use the new keyword. So here we say new person. So, okay, what's it going to do? It's going to go right into this, and it's going to pass these into the person constructor. Right? And this is how it makes an object. It has to call the constructor. So it's going to say this dot name equals name. Well, that means it's setting the name of the Bill object, like Bill object's name is going to be Bill. This dot age equals age. That means his age is going to be 65, city, Seattle, and gender, male. Then we do the same thing for Margaret. We set the Margaret object's name, so it's her name attribute to Margaret, her age attribute to 84, and so on, right? So each of these people have their own attributes, and like the attributes might be like of the same type for both of them, but they can have different values because these like are just different instances of a class. So just like with string, right? String, you had multiple strings and they might be different, right? But yeah, they might be different, but they both come from string, just like these both come from person. So any confusion so far? No? Okay. Oh, yeah. So this, in general, you don't really need to use this because this, like you can always use different variable names, but this, in this case, you do need it because what this is, it just means the variable that belongs to this class. So in this case, this dot name refers to the class variable, which is this one, right? Because this one is an attribute of this class. So this specifically means we're referring to this name instead of this name. So it's a way of like distinguishing between this one and this one, right? This dot name just refers to the one like that just belongs to the class instead of just the method. Yeah, no problem. Okay, cool. Nice one. Okay, so yeah, a couple more examples. Like you might have methods, like we were saying, right? Everything has a method, and then you might have data members. So like the data members, everyone like might have a name, an age, a city, a gender, and every car might have a model, color, and brand. And then they might have methods that also give you a little information about them, right? So like a person can go eat, or can go study, or can go sleep, or can go play, right? And so those are things that a person can do, and then we can call them and it'll do them, right? And the same thing with like speed and size, but those might also just give us information. But in general, like methods can give us information, or they can, right? Or they can like actually do something. Like if I said, oh, eat, then it might like add something to their weight or something like that. Yes, Keller, it is required. Right, and it does have the same name as class. Yep, absolutely. If you don't write a constructor though, like one will be provided for you, just takes no arguments. So in this example with person, if we didn't write a constructor, it would end up just looking like this. It would be person, and then it would just be this. That would be it. If we didn't write one, it would just be completely empty, and it would provide it for us. We wouldn't have to write it if we didn't have a constructor in our. But yeah, every class needs, or yeah, every class needs a constructor. And so yeah, as I was saying, like methods can either give us information, like can give us the speed of a car, or it can like, with the example of eat, maybe can add like something to the weight of the person or something. I don't know. Okay. So that's kind of how we can think of objects. Is they have like they derive from a class, like they come from a class, and they have attributes and then methods, which we can call on them. Okay. So yeah, so some a review of the access modifiers. So access modifiers, that's just like kind of the scope of it, right? So like you don't really need to worry about so much about the none or the protected. I mean, those are relevant, but like protected is subclass access, but we don't really know much about like subclasses yet. And that's what I was talking about earlier with overriding and overloading. We'll talk about more about that like next week. But oh, actually, I said overloading. You kind of no, you do need an overloading. So I will go back to that. Yeah, I forgot to mention that. But anyway, yeah. So like protected is subclass. It's just like we'll worry about that like next week. None just means like you can access it anywhere in the project you're working on. But private means you can only access it within this class. So if I have a private string owner here for a car, then that means that this car can only be, like this owner can only be accessed within this class. And like if I had another class here, like my program, I can't actually do like, if I had my first car, I can't do my first car.owner. Like this is not okay because it's private, right? But this is okay because brand is like kind of like public. Like this should almost always be defined. So let's just call it public, right? And that's perfectly okay because we can access it because it's public. And yeah, so that's kind of access modifiers. And also I just want to go back because I realized that I said something wrong earlier. So yeah, somewhere here. Yeah, overloading. I should have, yeah, I was thinking overriding. But yeah, talk about overriding next week. But overloading just means that you can have multiple constructors or like multiple methods that just take different parameters. So like with a constructor, I can have like person, right? For the person constructor, I can have just an empty one. And then if I wanted to, I can also have one that like takes an argument, right? I can write it so it takes like a name, like string name. And that's what it means by that. But like you can have multiple, and this goes with any method. You can always have like multiple methods that have the same name and type and whatever, as long as they have different parameter types. Okay. I hope I didn't confuse anyone by going back like that. And hopefully I haven't lost anyone. Does anyone have any questions so far? Okay, if not, thumbs up. Cool. All right, awesome. Yeah, I guess move on. All right, so yeah, let's do some live coding. So hopefully you guys understood everything we talked about so far, because now I'm gonna go ahead and like, well, we're gonna work on it, right? So yeah, I'm gonna go ahead and use Replit again. Just makes things easier. So right, I'll write my code here. Yeah. So let's first look at what we have to do, right? I didn't really look at that carefully. So let's do that first. So yeah, we need to make a private, like 3 private fields: age, name, GPA, a constructor which sets the name, mutator methods which are like setter methods. I prefer to call them like setter, so let's call them like setter. And then accessor, which is just getter methods. So setter and getter, which set the name, age, GPA, get the name, age, GPA, and get average GPA. Like, I don't know. I think this is like, I came up with this. I think this is like really silly, but like, it's fun, right? Average GPA, somehow your average GPA is your GPA divided by your age. So like, it's a new thing I just made up. So you're welcome. Yeah. So, okay, so we're gonna go ahead and write that, right? So I'll put this on the right, this on the left. And yeah, okay. So first we need to make our class, right? So public class student, in Replit I have to just write class student, but it's the same thing. So, okay. So the first step is to make our private fields, right? So let's go ahead and do that. Let's go like private string age, right? Because every student has an or a name, sorry, private string name. Every student has a name, right? And every student has a GPA. And GPA is like a double, so we'll do that. And every student has an age. And that's an int. Okay, so these are 3 things that a student always has. And well, notice they're private, right? So what does that mean? Well, since they're private, we can't access them directly, right? If I were in another class, I can't do, oh, if I made a student, I can't go, oh, like a.name because it's private. So how do I access it? Well, I need a getter method. And a getter method allows you to get it outside. But okay, we'll get to that in a second. First, we're going to define our constructor. The constructor is going to set the age, or sets the name, sorry. So what I mean by that is something like this. So I'm going to do student. It's going to take a name, student name, and it's going to say name equals student name. Okay. So here we're just setting the name of the student, right? We're going to pass it in a student name, and we're just going to set that to the name, right? Okay. So yeah. So what's the, now we have a constructor done, right? So now we need to make our mutator methods, or our setter methods, right? And our getter methods. Sure, yeah, no, that's a good question, actually. So why do you use a, that's, I like that question. Yeah, why would you use a private variable? So there are a couple of reasons. So one is like, it's kind of like the programming paradigm of like, or just like the way you do object-oriented programming, because you want to kind of encapsulate everything within inside of a class. If you make it public, then it's not really so much an attribute of the object. So part of it is like how you think of the object, right? You think of an object as having these things. So you want to like have them like encapsulated within that object. So like these are just things that a student has and you can only access if you're a student, right? And then you want to like kind of like separate getter and setter. And a big reason why also. So like that's kind of like one reason would be how you think about it. But like the real reason might be kind of to make it a little more secure or like a little more, yeah, so a little protected a little more. So like, for example, you don't want to be in another class and accidentally like set it. So in this case, we're being kind of explicit about how we get and set. So you can only set with a setter method and only get with a getter method. So in another class, I can't like have, like if I have a student named Andrew or something, I can't do like Andrew.age and accidentally like change the age. So that's one reason. And another thing is like, it is a little more secure in a way because you don't like give access to it from other classes. So that means that you can kind of define what you want people to have access to. So for example, if I wanted to have, if I didn't want to give anyone access to be able to set the age, for example, right? Because I don't want anyone else to be able to change the age, but I want to be able to do it from this class. Then maybe I have a method in here that changes it, but I don't have like a getter method or a setter method for the age. So that way other classes, like people who write other classes, can't actually access the actual data in here because it only belongs to this class. So does that kind of answer your question? I know that was like kind of long-winded. Okay, so yeah. Okay, cool. So the difference between a constructor and a mutator. Okay, so a mutator or like a setter. So okay, a constructor is what's called when the object's created, always. And you don't necessarily have to have anything set. So for example, like I could have all this taken out and like that would still be a constructor. So I'm not necessarily setting anything. So I could also set multiple things in here. So I could have like GPA, like, and then I could have like this dot GPA equals GPA, right? So I'm setting this one's GPA equal to that. So like a constructor sometimes does act kind of like a setter because it sets values sometimes, but it can set multiple ones for one thing. And then the other thing is a constructor is always, it can also set nothing. And it's also always called when the object is created. And it has to be for the object to be created. A setter is just something that changes data throughout the program. Oh yeah, so this, okay. So the this keyword, yeah. So yeah, the this keyword just means the one that belongs to this class. So in this case, these are my class variables, right? Name, GPA, and age. So if I do this.gpa, that refers to this one. And then if I do this.gpa equals GPA, like this is not this dot, it's just GPA. Yeah, I would. Yeah, you're completely right. I would have to do that. And I can even do it anyway if I wanted to. I can do like this dot name equals student name. That's perfectly fine. But there's no need for it, right? But yeah, you could totally do that. And so for, yeah, this just means like any class variables. So these three, right? And if it's like defined inside a method or whatever, you won't ever use this stuff. Okay. Good questions, by the way. These are like really good. So, awesome. I just need some water. Okay. Cool. So, yeah. Sorry, Keller, did that? Yeah, hopefully clear. Okay, so now we've defined our constructor, right? It sets the name. And so what's next? We need to define our setter methods, right? So we're gonna have public void, and setter methods are generally void because you're not actually returning anything, you're just like setting it, and that's it. So I can do like public void set name, right? And this is a way of like setting the name. So I would just do, oh, it has to take in a new name. So I can do like string new name. And then it would be like name equals new name, right? It's setting the name equal to the new name. So it's setting. And just like before, I can use like this dot for name. That's okay there. Yeah, exactly. That's right. And it doesn't like, yeah, it's a way of specifying. And you can, with those class variables, you can always write this dot and it'll always refer to it. So like even here, like this dot, anytime I'm talking about this one, I can always like do this dot name. That's perfectly okay. And that's all it means is that it's, yeah, the class variable and not some other variable, right? So actually, I may as well just do it anyway. This dot name equals new name. And yeah, but I don't have to. Actually, I guess I won't. So yeah. Okay. So that's our setter for name. And then the setter for the other two are like similar. So I'm just going to go ahead and copy because it would take longer to write it out. So let's do like set GPA and new GPA. And then we're going to set our GPA equal to new GPA. Then we're going to like do the same thing for age. So like set age. New age, and then like just age equals new age. So this is just setting the three different class variables, right? But then we also wanted to have getter methods, right? Because they just set. We don't actually have a way of accessing these still because they're private. So in order to do that, we need to have getter methods. So let's go ahead and write those. So for example, for the, if we're gonna have the getter for the, for the name, what do you think it's gonna return? What kind of data type or what kind of variable? For name. Yeah, that's right. Nice job, guys. Yeah, exactly. Right. Yeah, because we're going to be returning like the name, which is a string. So we're returning a string. So public string get name, right? And it doesn't take anything in because we're just returning the name. So okay, almost right. Oh, do you? So like, yeah, almost. If you're talking about the constructor, then yes. So like I could make a constructor. I could make like, all right, I'll say this a little different. Yeah, I could set all three at once if I wanted to. Like that's totally something you can do. Let's just copy it before in case it deletes it. But yeah, you could absolutely have like a setter for all three. Except you'd have to like then in that case set all three at once. It would, it's not necessarily overloading. Overloading just means that you have multiple methods with the same name. So if I had, for example, I could also have something where it's just like, I don't know, let's say I just had like public set public void, and for some reason I just did this, like void set GPA, and for some reason it took a string name and then I set my name there too. And that would be an example of overloading. Obviously, you probably wouldn't want to do it this like this necessarily, but this would be overloading because it takes different parameter, but has the same name of the same name method. That's all. Yeah, exactly. Same name, different parameters. That's overloading. Yeah. Okay. Cool. Yeah. So in this case, like for the get name, we're just returning the name, right? And it's going to be the same thing for the other two, just different data types. So I'm just going to go ahead and copy those over. And for the GPA, it would be a double, right? And so we're going to do get GPA. And like this ends up being like a lot of code, I guess, but notice how like it's a lot of it is like similar. So I guess that's one good thing about this. Right? Like get age, return age. Okay. So the next thing we have to do is just one more method, right? We're going to define get average GPA, which is something that, as I said, I made up, not a real thing in this, well, not in this way anyway. Right. So let's just write it, right? So it's gonna, we're gonna return an average GPA. I guess let's return a double, right? Get average GPA. So what are we gonna write inside of it? Well, we have to return double, right? So return. Yeah, exactly right. GPA divided by age. Nice. Cool. Yeah. And so we're just going to divide the GPA by the age, and that's what we're going to return for that. So notice like we have an extra method here that isn't like, we're not just having these set and get. Sometimes we can have like more information where like we can do some math or something, and it might mean something else. So yeah. Okay. So those are the things that a student has. Cool. Okay. So, okay, well then what do we do, right? This is a class, but we want to have objects, right? We want to make objects with that class. It's not, the problem is like a class itself is just this code. It doesn't really do much for us. But now let's make some objects. Let's see what it looks like, right? So I already have a driver class written. So let's go ahead and just copy and paste. Like it's just generally in like IntelliJ, you would have like separate files and that would be a good thing, but it's just this particular editor. You just have to have it in the same file, which isn't a big deal. It's just imagine they're in different files. It's just two different classes. But anyway, let's go ahead and test it out, right? So I have some code here, and I'm just going to comment everything for now, and then we'll go line by line, right? So the first thing I have is I make a new student. So let's go ahead and run it and let's see what happens. Yeah, so let's do Java C. That just compile. This line just compiles it. Driver.java. Oh no. So what do you think is going on here? Why did this fail? Any ideas? It said it failed at this line. If we look at our code here, right? So I guess I should put less space in between the two. But yeah, any idea why this might have failed, this line right here? No arguments entered, right? Okay, cool. Yeah, that's right. Well, okay, sort of, right? Yeah. What happens if, oh, I just meant to leave it a string. What happens if like I were to comment this out, right? Just this method here, just the constructor. What would happen? Right, it'll work. Yeah, exactly. Right. Why is that? Yeah, exactly, right. The default constructor is provided for us. Yeah. But remember, like if we don't write the default constructor, right? Like if we don't, if we write a constructor, then the default constructor is no longer provided for us. So like this, we wrote a constructor, so the default one isn't provided for us. So we can't just do this. So if we wanted to do that, we have to write the default one ourselves, or the no argument one. So we'd have to do like public student, and it can have nothing in it. So that's exactly what we would do, right? But it's not provided for us because we wrote another one. So now hopefully it'll work fine. Yeah, and it did. So that was exactly it, right? Good. And yeah, it just ran. But so far we haven't done anything. So let's go ahead and do this. What do you guys? Okay, actually I'm just gonna run it and then we can see. Okay, so why do you guys suppose that happens? Why is this giving us 0.0? Even though like I haven't set it yet, I've just made a new student. So what's going on? Yeah, it's a default value. Yeah, exactly. That's right. Because like student is a reference type, right? So like it has these attributes, and just like with the arrays, if you don't give it a value, it makes a default value for you. So like with the GPA, we'd never actually set it to anything at any point because we just called this one. But because it's an object like this, like we made our object student A, right? It's going to give us the default value. And in this case, that default value just happens to be 0.0. Okay. So yeah, very good. So, right. So it's perfectly okay, even though right here, it looks like we didn't set it to anything. Okay. So now let's do this. Let's do student b equals a and then v.set GPA. Okay. So what do you guys think is going to happen if I run this code so far? Like after this one, just, yeah. What do you think it's going to print out? 0.0. All right. Yeah. Cool. All right. So let's run it. Let's see if you guys are right. Yeah, you guys are right. Very good. Yeah, it's 3.0, right? So yeah, and like as I'm sure, as it seems like you guys noticed, right? Like because student is an object, right? And it's like a reference type. So like when we do student b equals a, what that means is that because a is like somewhere in memory, right? Like let's say it's like here in memory, that's what a is, right? So then when we do b equals a, we never use the new keyword. So it's not going to make it's not going to make new memory. It's just going to say, okay, b equals a, so b points to the same place as a. So when we change the GPA, let's say we set GPA equals 3, that's like a part of a, so I'm just like making a part of it. Yeah. Then it also, or when we do b equals b's GPA 3, that also changes a's GPA to 3, right? So yeah, very good. Cool. So yeah, that's like it for classes. That was cool. I just wanted to add like one more thing in here, just in case, because like you might not need to like elaborate anything, but it's like good to know in general, like for quizzes and whatever. I don't know, not even quizzes, just like in general. Yeah. So now if we make like a static int student count, right? And let's say inside of our constructor, right? So like we do student count plus plus. So we're incrementing our student count. And here we have student count plus plus. So what I'm saying here is we have a student counter, right? And every time we make a student, we're increasing that counter. But it's static, it's not private. So, no, it's that's not the same thing. But like it's static, right? We didn't like make it anything else. It's a static variable. So now if I uncomment this code, right? Now we have access to this static variable. So, okay, what's going to happen here? I have student count plus plus. Can I do that? And like, okay, and then I make a new student, James, and then yeah, it keeps running. So what do you guys think is going to happen here? Like, what's it going to print out on this line? One. Okay. Yeah, I don't think it gives an error because it wasn't initialized. I think you might be right though, actually. I think you are. Yeah, let's just set it to 0. But I don't remember if it, I think I do think it would give a problem, yeah. But I mean, we can try it out in a second. I just want to see what you guys, let's just say it's 0. But yeah, good call, Logan. But what do you guys think? Any, yes, yeah. So, okay, let's go ahead and actually, before we even run the code, let's try and think about what would happen, okay? So it's static, right? So what that means is that it's not, it doesn't belong to a class. Like static variables and methods are not class methods. So they never belong to a class, or like they never belong to an object, right? No, they belong to, they belong to a class. They don't belong to an object. So not one particular object, just every time anything like is on with this class, it belongs to just the class. So in this example, let's like look, okay, right? So it starts at 0, but then I say student A equals new student. So what's it going to do? It's going to say, okay, it's going to call the constructor of student, this one here, and it's going to say, okay, student count plus plus. So now student count is 1. And then it's going to say student B equals A. But it doesn't call the constructor. It just sets it equal. So we don't increase the student count because we didn't actually add a new student. And notice that the only time we ever incremented student count in our code was inside of the constructors. So because we didn't call the constructor, we don't increase the student count here. But here we do, because we're saying on that class increases student count. So now it goes from 1 to 2, right? Because it just belongs to the class. So we can do student dot student count. And then here we're making a new student, James. And that's going to be inside the constructor. We increase the student count to 3. So when we print it, we should get 3. Because even though it's a dot student count, because student count is static, it just belongs to the class. So every time we increment student count, it increments it like everywhere, because it doesn't just belong to one object. It belongs to like the class. So any instance of the class has access to that variable, like can increment it, if that makes sense. So let's go ahead and run it and make sure that like I'm not just saying nonsense, because that happens. But yeah, let's go ahead and run it and see what happens. Yeah, so 3. And okay, I guess just to test it out, because I'm kind of curious at this point, what's going to happen? No, I guess it does work. Yeah, I thought you were actually right about that, Logan. I guess we all learned. That's good. I definitely learned from that. So thanks for asking that question. Appreciate it. So student. So, oh, why does it cut 3.0 to? Oh, the only reason for that is because like it's a double. So if it doesn't have to go to extra decimal places, it doesn't. It's just gonna basically be like, oh, it's 3, but it's floating point. So it's just gonna truncate it to 3.0 because 3.0 is equal to 3.00. So it's just gonna give the smaller one. Like in terms of how long the string is. Okay. Anyway, so that hopefully like everything made sense. There did the static int student count kind of make sense to you guys, or not really? Or like, yeah, if you guys have questions, like, for sure ask. The problem solving slides, yeah, we can go back to those in a minute. I want to finish the rest of the slides first, but then we can go back to this problem solving afterwards if you want. But any other questions here about like that static or anything else actually? No? Okay. All right. Cool. seems like no questions. So then we can go back to finish the slides, and then we can go to the problem solving quickly, and then you guys can do the lab. Okay. So let's go from the current slide. So no questions, right? Thumbs up again. You guys are good. Just want to make sure. So far, good. All right, awesome. Cool. Okay, then yeah, let's go from the current slide. Let's just go ahead and finish this presentation. And let's just talk about what we're going to be doing for this lab. Yeah. So for this lab, we're going to be writing. It's the CalState lab. The good news for you guys, you don't have to use the terminal, but in the past, like you always use the terminal for this lab, but that's okay. It's kind of like using the terminal, but you're not really doing it. Yeah. So as you guys have noticed, like throughout the semester, probably, like when I used Replit, like the website I was just using, like I'll write something like this, like Java C, then the name of the file.java, and then the Java name. So all that does is like, that's what you do when you run the terminal, is like you just compile it with this line and then run it. So now you guys know what I've been doing. So, okay, but all right, well, now what? Like we always, whenever we run a Java file or a Java program, right, with a main, the main takes in a string array, right? But we always just write it. But we know what a string array is. We've just never used it before, which is weird. But okay, well, why is that there? Because you can actually take in arguments, right? This string array, in all the cases that we've used in the past, is just empty because we don't pass it anything. But you could pass it something. And that's what you're going to be doing in this lab. So in this lab, you're going to be passing it arguments. So, and those arguments are going to be inside that string array. So like with Java CalState-n, cow name message, like those are 3 arguments we're taking, right? Or yeah, or I guess it's, sorry, 2 arguments because cow name message is 1. So good question. No, they can't run without it. Like you're not using it, but in general, just Java requires you to write those. So even if you're taking no arguments, you still have to like explicitly write you're taking arguments. Yeah, it's just convention that you have to follow. But yeah, you always have to write the string args. But now you can actually use them. So yeah, so like for example, now the 2 arguments would be like dash and then cow name message, right? So it would take those in, and then you would use them as like you would use these arguments however you want. So you could say, oh, like if sub 0 is n, then or dash n, then we do this, like do something, and then you can go from there. So you can kind of split it into cases based on what the arguments are. But how can we do without terminal? Well, I mean, okay, you can on IntelliJ, you can like simulate the terminal. So you can just after edit configurations, you can edit the program arguments, so it still takes in arguments, but you don't have to actually like use like the command line. You can just do it here. Okay, and then you can just run it. All right. So for the class cow, okay, so that's kind of what we're doing because it's taking arguments. But for the class cow, because we're going to be making a couple of classes here, we're going to be making a class cow and then yeah, another one. So like for the cow class, it's kind of like what we were doing before, right? You just have attributes and then you have methods. So we might have a constructor, a get name, get image, set image. So what kinds of attributes we need? What kind of private variables? What kind of, yeah, what are the methods? So on. Yeah. Yeah, and then there's hypergenerator, which is written for you. And in your main, so basically like this is how the code kind of is structured. Okay, so what you're gonna have is you're gonna make a cow, right? So you have a cow, right, that you make yourself. And then in the hypergenerator class, it's gonna like make cows for you. So it just like you don't have to make the cows yourself. Like you know how before we were doing like student A equals new student. Well, here it just happens to be like that's the hypergenerator class is doing for you. It's just making the cows. So you don't actually have to write that in your main or anything. But you make your cow class, and this is what like you have to make the class. The hypergenerator just makes the objects for you and puts them in an array. So now you have an array of cows. So you have like a bunch of cows, right? And then you can get them, and then in your main, you get the cow array, and then you can do things with them, right? Yeah, sure. You mean like this way? Oh yeah, like if you guys want to take like a picture of this slide or something, I guess you can do. Oh, yeah. Sure. So yeah, this is like the command line one or the terminal one, yeah. And then like this one's intelligent. Okay. Cool. All right. Yeah. So I'll send it out to you guys like during like while you guys are working. Yeah. Okay. Yeah. So like when you do the cow array, like this makes an array of cows. So this is what you guys are going to call inside of your main. You're going to say hypergenerator.get cows. And you're gonna, that way you can actually, it makes the cow array for you, but this actually just gets it. So now you have a cow array in your main. So now you don't have to hard code your cows, you have them. So now you have like an array of cows. And for each cow, you can do something, right? So if I want to get, if I want to look for a cow with a certain name, maybe I can like loop through the cow array and say, and keep going until I get to one with the name I'm looking for, right? Like, because cows are just objects, they have attributes, right? So cows have names, right? And they have other things, right? So, or they have images. So if I wanted to, I could go, oh, cow dot get image or whatever, right? And that would give me the image of the cow. Okay. So yeah, your cow state class is where your main's going to be, right? And then you have to take in like these argument. You might have to take in arguments, right? And based on whatever arguments you get, you're going to have to do things with them, right? You're going to have to decide what to do. Now you hit -n, then you're just going to print out one with that count. Okay. And yeah, and to test with the provided script, like you just test it, and hopefully it matches the output exactly. And if you have issues, right, you can just run this. I'll send that out as well. Okay. So that covers this discussion PowerPoint. I know it was really long, so hopefully you guys stayed with it and you're almost ready to work on the lab. I know I said I'd look over the PowerPoint really quickly, so I'll do like 1 or 2 questions from that. Let me stop sharing really quickly and then I'll share again from the discussion this past, or the class this past week. And then I'll break you guys into breakout rooms, but we'll do it quickly because yeah, I want you guys to have time to work on the lab. Okay. Yeah. So, all right. So I'll share my screen for this for like a minute or two. Was there a question in particular that you wanted to go over with these slides? Because I don't really think I have time to go over all 5. Okay, so maybe I will go. Yeah, but okay, so let's go like 1, 2, 4, or yeah. So right, 1 is the error one, so let's talk about that. So you have a test, right? Or I guess 2 is as well. So you have test, you have data. So this doesn't, I don't think this does give an error because inside of main, we're saying new test, right? So it's going to make a test object and it's going to print out test.getData. But remember, data is initialized to 0 to begin with because it's an int, so it gives the default value of 0. So like we saw in the code I wrote earlier, this is just going to default to 0, so it's going to print 0, and then we just set data to 3, and that's perfectly okay. This .data is just this one, right? Like we talked about it. Okay. So this doesn't give an error. Like everything there is okay. The second one, though, is a little bit different, right? Because the problem with this is we also talked about something similar earlier, where we said, okay, new test, right? But the problem is that this here we're looking for the default constructor. The problem is we defined a constructor that takes an argument. We don't have the default constructor, but we have a constructor. This default one isn't provided for us. So this gives an error, just like we saw in the code I wrote earlier as well. Okay. And for 4, what's the output of the following snippet? Yeah. So this is also kind of like something we talked about earlier with static variables. So here we make new boots, right? So it's going to say, okay, increase the count, but count is static. So count is 1, and then new shoes. So count is 2 because this one here, we make new shoes, right? And so we call the constructor and it increases the count. And then we're also able to do shoes.count plus plus because it's static, it'll increase the count everywhere, and boots.count plus plus will also increase the count everywhere. So when we print it, it'll print 4 because it was static. So everywhere it increases it. Okay. So I know I didn't go over that for super long, any of those, but they're kind of similar to stuff we talked about earlier. So hopefully, I mean, was anything I know I went quickly just now, but hopefully that made sense. Does that answer those or not really? Okay, cool. All right, then I'm gonna split you guys into breakout rooms now. So yeah.